Today I'm here with the Creality Ender 3 V3 KE, and now that is a bit of a mouthful and yet another variant to the Ender 3 lineup. And personally, I think the Ender 3 lineup is getting a little crowded at this point. Hopefully they start phasing out some of the other variants. Now at the end of this video, I'm going to tell you guys which of the Ender 3s would be my first choice, as I've owned almost all of them at this point. But let's focus in on the KE itself for just a moment, and it's competitively positioned in price pretty close to the Bambu Labs A1 Mini. That's of course without the AMS system, and unlike the A1 Mini, the KE has a much larger build volume, and it also features, similar to the A1 Mini, a linear rail motion system on the X gantry, but unlike the A1 Mini, the Creality KE uses a linear bearing system on the Y-axis. The KE runs on Creality OS, which is basically their version of Clipper, and it has the Creality Sprite direct drive print head. Now compared to the regular size A1 from Bambu Labs, the A1 does have a slightly larger build volume than the KE, but features a similar construction where you have the two uprights, and unlike the A1 Mini, these two machines don't have the cantilevered gantry. And so while these machines are a bit similar in that regard, the A1 is priced considerably higher, and it would seem like Creality is trying to very aggressively price the KE to be a convincing choice over the competitors. Now we can talk about price and specs all day, but you guys are here to see what this machine is actually all about. So let's get started unboxing it, assembling it, and get down to business with printing.
Let's begin with the unboxing, and the Ender 3 V3 KE comes packaged in a sufficient amount of foam, and so I'm very happy to report that everything arrived in great condition. The top layer of foam has some of the accessories as well as the instruction manual, and below that you'll find the printer itself, so the base and the gantry with the print head. I've taken them out of the foam and put them on the table for you to see, and this is really the bulk of the printer, so there's not a whole lot to it. There's very few parts to put together. The included accessories are all pretty standard parts for an Ender 3 V3, things like side cutters, tools, spare nozzle, some grease for the linear rail, spool holder, instruction manual, and the screen. The assembly is going to be really easy, but if this is your first printer, I'm going to walk you through it. And so the first thing we're going to do is we're going to take that gantry, we're going to be installing it on top of the base, and you've got to feed in this one electrical connector onto the left-hand side of the base through the hole in the base. The two upright aluminum extrusions will sit in those pockets in the base, and then you can flip the printer on its side very carefully, and you'll complete the connection with the connector that you put through the hole on the left hand side of the base. In the accessory kit, you'll find 6 M3x14 socket head cap screws, and those are threaded in from the bottom of the base into those upright aluminum extrusions, so you'll do 3 on each side of the printer. Just remember that these are fairly small screws and they're being threaded into aluminum, so don't go too crazy tightening them. Now this is an extra step that you don't have to do, but I've removed the pan on the bottom of the printer to double check some of the electrical connections, especially the ones on the power supply as well as the screw terminals, and I just give them a slight wiggle with my hand and make sure they're not coming loose. Again, this is optional, but it gives me peace of mind when I'm running the printer for long periods of time. Then we can grab the 2 M3x8 socketed cap screws from the hardware bag, and we can secure down the plastic bracket on the back right hand side of the printer. On the left hand side is where the Z-axis stepper motor is, so there's not the same bracket. Also on the right hand side of the printer, this is where we are going to be attaching the screen. You'll find 3 threaded brass inserts for the M4x10 button head cap screws that attach the screen to the side of the printer. There's also a flat ribbon cable coming out of the side of the printer there that we can plug into the back of the screen. And on the back right hand side of the printer, we can also attach the connector to the Z-axis stepper motor. And then we can take our main flat ribbon cable harness that's going up to the print head area, and we can put that into the strain relief. There's a sticker around it which shows you exactly where to place it. There's a small connector coming off of it that we're going to plug into the X-axis stepper motor, and then the connector on the end of the ribbon cable will get inserted into the print head. There are 2 clasps on either side of that connector that we can just push inward to make sure it's nice, tight, and secure. In one of the plastic bags, you'll find a small plastic strain relief bracket, and that's going to get installed around this ribbon cable to make sure the connector doesn't get pulled on during the operation of the printer. Next, we can grab our sheet metal spool holder with the built-in filament runout detection sensor. Make sure the arrow is pointed down, and then we can use the remaining 2 M5 button head cap screws to secure that to the top of the printer and plug in our filament runout detection sensor. The plastic portion of the spool holder is next. The nut just simply unthreads by turning it counterclockwise, insert it into the top of the sheet metal bracket of the spool holder, and then just tighten the nut back down. At the back of the printer, make sure you've got the voltage selector set to the appropriate input voltage for your country, and then you can remove the stickers from the screen, and then we can take a look around the printer and do a quality check. And the first thing I notice here is that my nozzle is a little bit bent to the left-hand side, and even the bracket holding the entire print head doesn't look to be bent to 90 degrees. The misaligned hot end should be easy to fix, and we're going to do that. The bracket holding the print head, I'm going to leave as is, and we're going to see how it impacts the printing. I could fix it myself, I have the tools to do it, but for the average person, that's a pretty difficult bracket to bend back. And so I'm going to remove these screws on the right hand side and left hand side of the print head cover. That's going to allow me to pull the cover straight away from the rest of the print head, giving me better access to the hot end at the bottom, where I can pull down on the silicone sock, exposing the rest of the hot end. And what I'm interested in here is the 2 screws that secure the hot end up into the heatsink block above it. I had suspected that one screw was just way more tight than the other, and so I loosened them both off and then retightened them equally on the left and right hand side, and this seemed to fix my problem. Hopefully this was just a one-off problem with my machine, but if you have the same problem, at least it's not too difficult to fix. Now we can get our new printer set up, so we'll power it on with the power switch at the back, and we're greeted with a nice brand new Creality splash screen animation. It'll prompt us to select our language, and then we'll be walked through a series of other setup prompts. You'll have to agree to some privacy policy. You can set up your Wi-Fi password, your time zone, and all of these typical settings before getting into the printer self-check. This part of the setup is completely automated, so the printer will completely take over at this point, and it will begin to probe the print bed, as well as test things like the nozzle heater, the heated bed, and then it says it will clean the nozzle. The KE is fairly unique in the sense that it uses a CR touch probe in the back of the print head and a strain gauge sensor on the front left corner of the print bed to achieve the auto bed leveling, as well as setting the Z offset automatically. You'll notice that there are no bed level adjustment knobs, so this whole process is automated, and if it works, it will completely eliminate the need for adjusting the print bed as well as setting the Z offset with the traditional method of using a piece of paper. We're almost ready to find out, and first we have to load in some filament. Creality was kind enough to send me some of their white Hyper PLA series, so we can put that up on the spool holder, we can feed it through the filament runout detection sensor and down directly into the top of the print head. In the control section of the touchscreen menu, we can just click directly on the nozzle icon. I'm going to set the temperature to 220 degrees, and we can wait for the print head to heat up. And then I can just push on the lever on the left hand side of the print head, push down on the filament, and that will purge the nozzle, and you'll see some of the white filament come out. During this process, I also happened to notice that my gantry wasn't looking very parallel with the top of my print bed. And so what I did here was I took 2 of these metal blocks, they're exactly the same height, and you can use anything you have laying around, that's the exact same height. And with the printer off, I'm using the lead screw at the back left-hand side to raise the gantry up, rest the gantry on top of one of the blocks, and on the right-hand side, you can see here that my gantry is higher than that one block. So it is in fact crooked. To fix this, we can go to the back of the printer, and on the left-hand side, because this is the side that I want to lower down, I can loosen off the 2 grub screws on that pulley. On the right-hand side, I'm just going to turn that gantry to make sure it's resting on the block on the right-hand side. Then I'll hold the lead screw on the right-hand side still while I turn the lead screw on the left-hand side. The left-hand side lead screw should slip inside of that pulley because the grub screws are loose. And this is going to bring the left-hand side of the gantry down. It's going to touch the top of that block, and then I can retighten those 2 grub screws, and now I know my gantry is parallel with my print bed. If you have to do this on your printer, I'd highly recommend that you rerun the auto bed leveling process as well as the automatic Z offset process again before you start printing. Now we're finally ready to get started with our first print, and I'm going to be using Creality Print to slice these files, and part of the reason for that is I've had this printer since pre-release, and at that period of time, no other slicers had a preset for the KE. And so to get the KE set up in Creality Print, you'll go up to the right hand side with the printer selection, say add a printer. You can expand the Ender series tree on the left hand side, and somewhere near the bottom you'll find the Ender 3 V3 KE. It's got a 0.4mm nozzle from the factory by default, so you can add that printer and you'll see it appear in the top right hand corner of the screen. I'll select Hyper PLA from the material drop down list, and I'll double click on the print quality of 0.2mm. Not going to adjust anything in there just yet. In the top left hand corner, I'll click on the folder. It's going to open up a Windows Explorer folder, and then you can select an STL. And in this case, I've got this calibration cube that I've designed, and I've made these 30mm by 30mm calibration cubes available on my printables page. I'll put a link to that in the video description down below. And this calibration cube tests a few things like clearances, overhangs, as well as supports. So I went back and double clicked on the 0.2 normal settings and have enabled supports in the support section. Now I don't want to add supports everywhere, so on the left hand side there's a little support button. You can add custom supports, and when you drag your cursor around the model, you can see these red blocks show up, and when you left click they turn green, and you're placing these little support blocks around the model. And this needs support on the left and right hand side, and we go to slice the model and inspect it. On the very first layer, you'll likely see some purple brim, and that is connecting the bottom of our support with that interior square or cube, which is meant to test for clearances. So we don't want those welded together. Back in the settings, we can go into our build plate adhesion settings and disable the skirt and brim. And now when we go to slice it, you'll no longer have the issue of the brim connecting itself with that inner cube. So now we can properly test for clearances. One final setting I'm going to change is the support density, and that's of course in the support section. I'm going to increase the support density percentage, and that's going to increase the number of lines making up that support. Then when I go to reslice it and inspect it, you can see there are more of those light blue support lines, and they're closer together. This is going to provide us with a more reliable support. And then we're ready to send it off to the printer, so we can click the blue button in the bottom right hand corner of the screen, land printing. We can set the file name, and we can scan for printers on our network. Now obviously I'll be selecting the KE, and I can send it to G-code. Now if I had clicked one-click printing, it would just send the file and start printing right away. There's also a button that says details. This will bring up a status screen for the printer, but in this case I'll be walking over to the printer, clicking on the folder button, and you'll see this file had shown up. It was sent wirelessly through my Wi-Fi network. I've got the calibration button checked off right now, and I'll just confirm and start printing. If you leave the calibration box checked off like I did, you'll notice that the KE runs through the auto bed leveling process again, as well as the auto Z offset process, and then it will start printing. So this takes a little bit of extra time. If you want to skip that step, then uncheck that calibration box. This first print was a successful one for me. I very closely monitored the first layer going down, and the auto bed leveling process as well as the automatic Z offset seemed to work great because the first layer looked quite nice. Now this is a smaller print. Obviously I'm not testing the entire print bed here. We'll start off small and load up some bigger models later, but overall the print finished. I was able to very easily remove the part once the print bed cooled down, and the model looked nice overall. The supports came off very easily. There were just some very minor fine wisps of filament that were pretty easy to clean off. Now, unfortunately, the inner cube, which had a 0.1mm clearance around the whole thing, was welded to the outside. But to be fair, that's a very tight tolerance for a printer in this price range. And so I tried again with a 0.2mm clearance around this cube, and the two parts were still stuck together. It looked like the two parts were only attached in a few small spots, so I bet with a small bit of tuning, you could get this printer to get a 0.2mm clearance between parts, and that'd be quite good. But again, I'm showing you guys what this thing is capable of pretty much out of the box, and so I'd be willing to bet that you'd be able to hit 0.25 without touching any settings or doing any tuning. That's still very reasonable dimensional accuracy, and so I just went ahead and printed the 0.3mm version of this cube, and that came out nice, and there were no issues with clearance at 0.3mm. Now that I was finally able to get the inner piece out, it's easier to inspect the two parts, and you can see that the corners and details of the outer cube looked very nice. White filament is a little hard to see on camera, so we'll get into some different colors later. but all of the various overhangs and other features like sharp corners were quite reasonable on this printer. And again, this is without any further tuning. The KE is running Clipper, so it should be easy later on to do some adjustments and to tune for pressure advance, and that could make some of those smaller details even better. But again, right out of the box, very respectable. The corners look nice, and I'm happy with this result. Now we can move on to print a variety of different things, and in this case I'm going to be printing these battery adapters. So these are intended to adapt AA batteries to C-size batteries. I'm using the same settings as the calibration cube, but in this case I've disabled supports because the model does not need any supports. Then I can go through the normal workflow of slicing the part, changing the name, selecting land printing, clicking on the KE, and in this case I'm going to click on one-click print, so that'll send the G-code directly to the KE and start the print immediately. I figured these parts here would be good prints to test for dimensional accuracy as well as round walls, because a standard size AA battery should fit inside of them, and the round walls will give you some idea of how this printer prints round surfaces. Overall, I thought the parts looked pretty good. The AA batteries fit inside without issue, and the positive and negative symbols on the surfaces of these cylinders turned out nice as well, but I figured they were a little bit small, so it's time to move on to something bigger that might be a little easier to see, especially in this white filament. This time around I've got this 4-inch hose adapter that's got a flat flange surface, and this will be a little better for us to check out that first layer and see how that goes down, as well as a larger rounder surface for us to inspect. After starting the print, I noticed the first layer looked fairly good. It was perhaps just ever so slightly too squished, but it didn't look like it was going to cause any problems, so I let it just go ahead and run the rest of the print. The KE is impressively fast for a bed slinger, especially if you've owned any previous generation Ender 3 models that you didn't modify. Now, if you have been around other high-speed bed slingers, it's definitely not going to break your brain, but it is still going to look respectably fast. Now, with great speed and acceleration comes great potential for vibrations leading to print artifacts, so let's take a look at how this part turned out. Despite the first layer being laid down a touch too close to the print bed, you can see the bottom of the print still looks nice, and the KE comes with a textured flex plate, so you can see that texture was transferred to the print. Again, looks very nice. There's very minor elephant's foot on this part because of that close first layer. The round surface looks very clean. There's no waviness or signs of Z banding. You can see I'm pointing out the seam, which falls to the left of that letter E. And speaking of lettering, those came out looking clean. Overall, a very nice part. Now, a few moments ago, I mentioned vibration, and one of the next things I wanted to do was print something a little bit taller. The KE runs Clipper and it is capable of input shaping tuning, but it doesn't come with the sensor. So unless you buy that sensor separately, you can't take advantage of input shaping, and I was noticing my printer shaking back and forth quite a bit. So much so that this tall bolt that I'm printing got knocked off the print bed. The vibration is a little easier to see when I zoom in on these upright aluminum extrusions, and I think part of the problem is having a very heavy spool mounted high up on the top of the frame, so we'll address that in a moment. But without making any changes to the printer, I was able to fix that issue by reprinting the bolt with a brim. Having more surface area on the bottom of this part kept it on the print bed despite the printer shaking around. Despite all that shaking, the external square threads of the bolt still came out looking pretty good, and the internal threads of the nut were decent as well. They were at least good enough to fit together properly without any excessive friction or having to apply an unnecessary amount of force. Now, although those parts still fit together, all of that shaking did not sit well with me, and I just had to address that heavy roll of filament sitting on the top of that frame, which I'm sure is not helping with this vibration. And so I designed a few simple parts that will print right here on the KE, and I've made these files available for free on my printables page. Check the video description down below. Basically, these two parts are a PTFE tube guide, and they're going to take the place of the plastic spool holder sitting way up at the top of the printer. These two parts feature the same sort of twist lock geometry that the original Creality spool holder does, and to get these installed, we're first going to have to go into the control settings, and we're going to change out the filament. So we'll head up to extrude and retract, press the retract button, and the machine will heat up the nozzle, purge a little bit of filament, retract, and then we can get on with relocating our roll of filament. Here you can see the purge at the bottom, you can see the filament being ejected, and one thing I would highly recommend doing before pulling that filament out is releasing the tension on that lever. This will ensure that any remaining blobs of filament don't get pinched off by the extruder gears, falling back into the extruder assembly and potentially causing a future jam. Now we can twist off the old spool holder at the top, and we can install our new PTFE tube guide. You'll notice that this nut has two flats as well as a chamfer. The chamfer will face the back of the machine. The flats will sit inside of the channel at the back of the metal spool holder bracket, and those flat faces will just prevent the nut from turning while you install the front piece. I'll insert the front PTFE tube guide into the nut and turn it clockwise to lock it in place. And this is what the final result should look like, and if you've clocked the two pieces correctly, you'll see that my logo is sitting in the right orientation. Next, we need to relocate our spool, and to do this, I'm using my Spool Holder X, and this is an upgrade that I had originally designed for the K1 and the K1 Max, because on those machines, they had very inconveniently located their spool holders on the back of those printers. And so I devised the Spool Stand X to be a freestanding spool holder with a low friction spindle, where you can secure your filament in place, run it up through the PTFE tube guide and into your printer. And as it would turn out, the Spool Stand X will also work quite nicely with the KE, because I'm going to take the other end of my PTFE tube, push it through the PTFE tube guide that we just installed, and now the filament will come out that end directly into the top of our filament runout detection sensor. This means no more heavy spool at the top of our frame, and we still get the optimal filament path coming in directly from the top of the print head. Now I've got another very interesting spool holder solution that I've been working on, and I'll show you guys that towards the end of the video, so be sure to keep watching so you don't miss it. Now if you guys are looking for the Spool Stand X, you can find that on my website, embracemaking.com, and if you're watching this video even further into the future and you're looking for my next gen spool holder solution, you'll also find that on my website, embracemaking.com. So now let's get back into printing. I switched up the colors, so we're still using PLA, but it's black PLA this time, and hopefully we'll be able to better see some of the finer details of the print in black. When testing printers, I love printing off various types and sizes of threads, because the threads test a few different things, one of them being overhangs, another one being part cooling, and the last one being the dimensional accuracy, because if you have a male and female thread, of course they need to fit together. Personally, I think these parts came out looking even nicer than the Creality White Hyper PLA, and truthfully this is just some off-brand regular black PLA, nothing special here. My only complaint was that the first layer maybe just wasn't quite squished enough, but the two parts fit together and there were no serious blemishes or artifacts on them. So now I've seen one print where the nozzle was too close to the print bed and another where it wasn't close enough. Now luckily we can fix this with the Live Z adjustment. As I demonstrated earlier, the KE automatically sets the Z offset, but if you head into the controls and the adjust tab while you're printing, you have access to change the Z axis compensation live. A more negative value moves the nozzle closer to the print bed for more first layer squish, and this is a great way to fine-tune your first layers. In this video clip here, you can see in the top left-hand corner, the print started with the nozzle too far away, and after using the Live Z adjust, I got it just about perfect. Surprisingly, the Ender 3 V3 KE had this feature before the K1 and the K1 Max flagship printers from Creality, and it wasn't up until recently that they added that functionality to those K1 and K1 Max models. And before we inspect this next print, I just want to point out that when you go to start your next print, if you leave the calibration button checked off, then this is going to overwrite the Live Z axis adjustments that you just made. Therefore, if you don't want that value overwritten, then you'll need to uncheck this box before you start your next print. This model that we're looking at now, I chose because I wanted something with a little more surface area on the top layers so we can see how those would turn out, and of course demonstrate to you guys the Live Z axis adjustment that we just discussed, and also on this print some finer lettering on the top of the print to see how smaller details like that would turn out. The result was okay, but I wasn't overly impressed with the top layer or those numbers. This part was sliced with Creality Print, and later down the road, after printing with the KE for months, I found that switching over to the presets from Orca Slicer resulted in much better top layers. Another thing that I noticed after several months of printing was that the print bed was shaking around a little more than usual. If you own one of these machines, I would suggest that you periodically give your print bed a shake every once in a while and check the tightness of the 4 screws holding down your print bed. From all the vibration from printing, mine were definitely loose, and you'll notice that there are no nuts on the bottom of these screws underneath of the Y-axis carriage plate. The carriage plate itself is what these screws are threaded into, and so you don't necessarily need nuts. If you did add them, they would act sort of like jam nuts. I think they'd be a perfectly viable solution for keeping these screws from backing off, but in this case what I decided to do instead was just apply a little bit of Loctite. The thread locker should prevent these screws from loosening in the future due to the printer vibrations. This is future me inserting myself into the video before the review section that you'll be watching next. Spoiler alert, in the review, I'm going to say that I recommend this printer over the various other Ender 3 models. And this is still mostly true, but I do want to point out that I filmed the review shortly before receiving and starting to test the latest and greatest Ender 3 V3, which is technically an Ender 3 if the designation only requires the namesake and the build volume. Other than that, the Core XZ V3 is a significantly different machine than the rest of the Ender 3 lineup, and I really don't think that it's a fair comparison to the other machines. In my opinion, it deserves its own name and category in the Creality lineup. And so if you are somebody who still considers this new one an Ender 3, then technically I do think it's better than the KE, at least from my limited initial testing. Of course, it also costs more, so that's something else to take into consideration. That being said, I didn't edit my review because I still think the KE is great value and is easily better than the other traditional Ender 3 models. I put my money where my mouth is and I bought 2 more of these KEs for my print farm that I've been using regularly for quite a while now. The other reason I've created this video chapter is to show you some of the more recent upgrades and additions to the KE that I have available now and ones that I will have available soon. I already have a nice variety of these micro texture pattern transfer flex plates. They fit the S1, SE, KE, the latest V3 Core XZ, the K1, and I even have bigger ones for the K1 Max. They're gaining popularity as they leave a really nice impression on the first layer of your print for some added flair. Another thing I'll have available soon are kits for the Y-axis linear rail conversion for the KE for those of you who want more precision and rigidity. And soon I'll have another standalone spool holder that is a universal solution for the Ender 3 style printers. Be sure to subscribe so you don't miss these upcoming videos and visit embracemaking.com to check for availability. Now let's go back in time to my initial review.
So we're at the point now where I tell you about what I think of the KE, but first, earlier in the video, I promised to tell you guys which of the Ender 3s I would pick in the entire lineup because I've owned almost all of them at this point, and it would be the KE for both beginner and advanced users. At this feature list and this price point, none of the other models even seem to make sense unless you're looking for a bigger build volume, in which case then you'd be forced to choose between the S1 Plus or the Ender 3 Max. So this is where I really struggle to even understand why all of those other models still exist at this point. In some ways, I think the KE will even drive a lot of sales away from Creality's flagship model, the K1, and the K1 will always have the edge with the nicer enclosure, the stiffer frame, the Core XY motion system, but for about half the price of the K1, the KE will give you about 75 to 80% of the performance. So for a lot of casual users, this thing makes a lot of sense. But for how this thing stacks up against other brands like the Bambu Labs A1 Mini and A1, unfortunately, I can't really comment since I don't own any of those machines. Obviously, I can read off the spec sheets, but that doesn't do you guys a whole lot of good. Prints were processed quite quickly at comparable speeds to what I was achieving on my K1. Now, the max print speed as advertised is 500 millimeters per second, but of course that comes at the caveat of the print geometry and how the printhead can be accelerated. And speaking of acceleration, at 8,000 millimeters per second squared, that's a pretty respectable value for a bed slinger machine. And so basically what I'm trying to say here is that I was not at all disappointed with the speed of this machine. The advertised 500 millimeters per second, I'm sure you can probably hit that in some circumstances, but even the default speed value in Creality Print is set to 300 millimeters per second on this machine. The automatic Z offset on this thing works really well, and with some very fine adjustments with the live Z adjust, I was able to get perfect first layers across the entire print bed, and that live Z adjust is a very small feature that I appreciate a lot, especially considering that on the K1 and the K1 Max, at least at the time of the making of this video, those two flagship machines still don't even have that feature, whereas the KE does. Integration with Creality Print Slicer was a breeze. They obviously have a profile in there for the KE, and wirelessly sending files over Wi-Fi worked very reliably every time. Now, the biggest downside of this machine is that there could be some issues related to quality control, even though you guys pay a very low price for it. As you had seen earlier in the video, my nozzle and heat break came installed on this machine from the factory a little bit crooked. I was able to correct it, but that's not something that you'd like to find on your brand new machine. Now, hopefully with enough user feedback, Creality can address those things. The other thing I just generally don't like about the Ender 3 models, and this is the same across all of them, and even the Bambu Labs A1 and A1 Mini have it, is the wire loop that goes from the base of the machine up to the gantry. Something that I just don't like. I wish these companies could make the wire management a little bit cleaner, but I guess functionally it does work. And so that's it for this video. Be sure to check out my website, embracemaking.com, where you can find replacement build plates for the KE, as well as the Spool Stand X. And don't forget to check out my printables page, where you can find the free files for the PTFE tube guide that goes on the top of the KE. Thanks for watching.